Okay, so we are going to look into the second part of the wave, which is damping and resonance. Alright, this is a very simple thing. Okay, so it's going to be a very short video. Alright, but just to show you the effect, or what you call the meaning of damping and resonance. Okay, so if we talk about damping, right? Okay, when we talk about damping, meaning that the amplitude is decreasing. Okay, the amplitude of the graph, or the wave graph, is decreasing, as you can see here. Alright, and the reason why damping happens is because you have external forces acting on the oscillation, right? Maybe air friction. That's why if you let a spring what do you call, oscillate, right, it will slowly slow down. Okay, and then as it slow down, alright, that is what we call damping. Okay, the amplitude is decreasing, and the reason why it happens is because energy is lost. Okay, because they need to use up the energy to overcome the frictional forces. All right, but never mind, let's just watch a simulation, then you can see, okay, the impact or the meaning of damping here. All right, so I'm just going to show you a video here, okay, to show you the effect of damping. Okay, all right, so let me just fast forward to this part here. Okay, so this is when it's oscillating, right, up and down. You can see the wave ground is going up and down, right, and then it has a very high amplitude here. Okay, so this is before damping. Okay, when the spring is able to oscillate, okay, without any external factors lah, basically. Of course, this one after a while maybe it will slow down lah. Okay, this is the effect of damping. Okay, as you can see, one more time again. All right, one more time. Okay, let's look at the effect of damping. As you put into water, right, because you have friction here, right? Okay, so as you have friction here, as it goes up and down, alright, it will slow down. Okay, so technically that is what we mean by damping lah. Okay, damping. Alright, whereby the oscillations start to slow down, okay, because they have external forces acting on it. Basically, you have someone stopping you from moving lah. Okay, this is in oil, or immediately stop. Okay, you don't even have oscillation. Okay, but that is what we mean by damping. Okay, when we say damping, okay, meaning that you are reducing the amplitude of the wave. Okay, because energy is lost. Alright, so for a damping system, okay, your amplitude and your energy is decreasing. Okay, energy decreases, amplitude also decreases, but your frequency remains the same. Okay, what do we mean by frequency remains the same? Okay, I'm going to show you what do we mean by that. Alright, because they will ask you to sketch the effect of damping. Okay, they will ask you to show the effect of damping. So normally how we draw this is very simple. Alright, let me just draw back this. Okay, now we know that if it's damping, right, meaning that the thing will start to slow down, meaning that your amplitude will slowly decreases as time increases. Okay, meaning the shape is going to go down. So how do we draw this? Is normally I will draw these two things first. I will draw these two lines first. Okay, just two. This one. Okay. Okay, something like this. And then here also I will draw roughly the same thing. Okay, but I need to make sure that it's as accurate as possible. Okay, let me just remove this first. Alright, and then just this one. Okay, maybe not very nice lah. Oh my god, so terrible. Okay, but never mind. Okay, so when you draw the damping, okay, when you draw the two lines here, then you plot your graph, you reach the point here, boom, and then you come down. You just draw back exactly the same thing, just that you follow this one. Okay, up, down, then you can see that the amplitude is reducing, right? Okay, smaller amplitudes. So that is your damping. Okay, as you can see, the amplitude is decreasing lah. Alright, from the top position here. Alright, now when we say frequency is the same, okay, this is very important when you sketch for damping. If we say frequency is the same during damping, meaning that the amount, or what we can say is that the period should also be the same. Meaning, if let's say from here to here, this is, let's say, 5 seconds for one complete oscillation. Here to here is also should be the same. Okay, or in other words, an easier way for you to remember is how many mountains do I see here? I see 3 mountains, right? 1 mountain, 2 mountains, 3 mountains. When you draw, you also need to make sure that you have the same exact of mountains here also. Okay, 1, 2, 3. And then the period cannot be different. The period must be the same. Right, this one, the past already. The period should be here. Okay, here. Alright, meaning the period must be the same for damping. Okay, so when you draw damping or when you sketch damping, just make sure that the frequency is the same. When we say frequency same, meaning that the number of mountains is the same. Okay, you can use this to like roughly remember lah. So here, if I look here, I have 3 mountains here, 1, 2, 3. When you draw, or you also need to follow the same number of mountains here. Right? Basically, this tells you the frequency lah actually. Okay, but yeah, that is the effect of damping. Right? It happens due to external forces. Okay, air friction, right? Or maybe just now when you see the water there, right? Okay, it stops you or it slows down your motion, the oscillating motion. Okay, that is damping. Alright, so the next part we'll be looking at is the resonance. Okay, alright, if you look at resonance, right, the easiest way for me to explain resonance is that when the two objects is vibrating or oscillating at the same frequency. Okay, if you're oscillating at same frequency, you move at same frequency, meaning you are at resonance. Okay, so oh my god, look at her, so pretty. Oops, I hope people don't sue me, later kill me, man, later. Alright. Okay, that is what we mean by resonance lah. If you have the same frequency, alright, you are in resonance. If you are not in same frequency, you are not in resonance. Okay, so the characteristics of a resonance is that when both are oscillating at the same frequency, okay, meaning they will oscillate at the maximum amplitude. Okay, when two things are in resonance, they are going to oscillate at maximum amplitude. Alright, so I'm sure a lot of people have done this in your school. Okay, but maybe not lah because of the MCO, right? But it's okay. We'll just look at this example right here. Okay, of the resonance. Okay, using a pendulum lah. Alright, so the idea here is like this. Okay, when you start to move one of the balls, the other also will start to move, but only one will move in the same direction with the ball. Alright. Okay, so maybe from here, right, as you can see, alright, the black ball here is moving together with the orange one, right, compared to the other three lah. Okay, maybe this is not very clear enough, right, if they look it from the side. Okay, if you look from the side, it's more clearer. Okay, as this black ball starts to move, okay, the one, you can see there's one fella who will follow the black ball, which is the orange one, as you can see. Yes, alright. So this is what we call as when the two objects are in resonance, right? Meaning they are going to move at the same frequency, okay, compared to the other balls. Okay, so this is your resonance. Okay, resonance means that when you have same frequency, you are going to oscillate at the same time, maximum amplitude. Okay, and the reason why it oscillates, okay, is because of like this lah. Alright, in the case of pendulum, it's very simple. When you start to oscillate x, when x moves, right, all the other pendulums will move also, but only B moves together. Alright, B will move together with x, okay, at the same time, alright, at the same what they call frequency, because their length is the same. Okay, so this is your resonance. Alright, so the idea here is that when you have the same frequency, you are going to oscillate at the same, you're going to oscillate at maximum amplitude. You're going to move together lah, basically. Alright, so this is what happens when, you know, a glass shatters, right? When you shout or when you scream, you see people, oh, and then bang, that thing hancho, right? Okay, so so let's look at the video lah for the effect of resonance here lah. Oh, okay, you see this fella, they shout and scream and then it breaks, right? So technically what is happening here is that when you are shouting, right, your sound and the atoms in the glass are vibrating at the same frequency. So when they vibrate at the same frequency, they are in resonance. Okay, so when they are in resonance, they are going to oscillate at maximum amplitude, the highest amplitude, and then pom, it breaks. Right, so here they show us a very few interesting things. They capture it in slow motion, right, just to let you see how your glass vibrates, you know, when they put, well, not when they put lah, when they on the sound. Okay, so we are going to look at how resonance works. All right, so I believe they show us the slow motion that we can see here. All right, so let's look at the slow motion. There. Okay, so as you can see here, right, when the sound is on, right, okay, the air molecules is moving due to sound, and then the atoms of the glass also vibrates together, you know. So when both are in resonance, maximum amplitude, then they are going to crack. Okay, so if you see here, okay, the sound is going in, not going in lah, when the sound is on, right, meaning that the atoms are going to start to vibrate. The atoms in the glass are going to start to vibrate at the same frequency as the sound, and then when they are in resonance, it will pecah, break. Come on, break. Hello people, break, break, break. Hey, haven't break. Come on man, break. Hello, break. Okay. There you break. Alright, so that is resonance lah. Okay, oh my god, so funny lah. But never mind lah, that is the meaning of your resonance. Okay, when the atoms are vibrating at the same frequency, they will oscillate at maximum amplitude. Okay, so example is your radio lah. There's a reason why. Okay, FM, AM, right? Okay, FM, AM. AM, it does not mean you listen in the morning, radio. No, no such thing. When I was a kid, I also think it's that way lah. AM meaning morning you listen. No, it's not like that. This is called amplitude modulated. This is called frequency modulated. Alright, so for example, because I don't know where you guys are, for example, in Klang Valley, right? Klang Valley hits FM. Okay, if you listen to radio, hits FM is 92.9. This is the channel, right? Okay, so you need to adjust here, right? You need to adjust this thing, okay, so that you reach the channel here. So what you are doing right here, right? Okay, what you're doing right here is an example of resonance. Okay, so your car here lah. Okay, then your radio here. Give you a big radio here. Okay, so when you're adjusting, right, what you're trying to do is you are trying to match the frequency. Okay, so let's say this one is the radio tower lah. Alright, okay, you are trying to match the frequency that is being transmitted from the radio station. Okay, so the radio station is transmitting hits FM in Klang Valley lah, at 92.9 Hertz. Okay, so you are also adjusting your radio. So I'm sure you notice, right, as you go nearer to the to the station's value, it gets more clearer and clearer, right? And then once you reach this one, okay, 92.9, then you can hear very loud and clear. And the reason why you can hear loud and clear is because, alright, you are in resonance. Okay, the radio in your car and the radio station are in resonance. They have the same frequency. Okay, that is what you're doing in your radio. Okay, even for Astro is also the same thing lah. Okay, but yeah, that is the example of resonance, right? Why you need to adjust your radio's station. Okay, each station at different places, the the channel is different, because if it's further away, maybe they need to broadcast it at a longer distance, so the frequency that they need to give is also a different frequency. Alright, but yeah, basically that is the concept of your resonance. Okay, so damping and resonance. Alright, so for resonance, normally when they ask about resonance, they will ask about things in daily life. Alright, so you need to know like a few examples of application of your resonance. Okay, a guitar tuner, a piano tuner. Okay, when you are tuning, what happens is that the tuner and the guitar strings here are in resonance. Okay, so they are going to vibrate at the same key. Okay, then you are able to tune your guitar. Alright, but yeah, those are a few things, a few examples of your resonance. Okay, right, so that will be it for our video today. Okay, for this part, damping and resonance. Right, and the next part we are going to go finally into the phenomenon of the different type of waves. Okay, reflection, refraction, diffraction, and also interference. Right, so I will see you guys in the next few videos. Okay, bye.